By studying the hysteresis property of the ferromagnetic material, we can find the energy loss per cycle per unit volume, the remnant induction, and the corrosive field. We shall now do the experiment. This is the CRO, known as cathode ray oscilloscope. This knob is to vary the intensity in the CRO. This is the focus. This to illuminate the scale. So here the XY mode has to be pressed. Pressing this will deactivate the timer. The time is not taken into consider when you press this XY knob. You can move the spot up vertically when you turn this knob. And the knob is directly above the white channel of the CRO. This knob is for the horizontal movement of the point. This is for fine adjustment along the horizontal direction. So this knob is directly above the X channel of the CRO. Make sure all of them are in the AC mode. This is volt per division. The switch next to it should be kept in the AC mode. So this is an auto and internal. The trigger level is in the lock mode. The calibration should be locked in both the cases. So now make sure the point is exactly at the origin. Once the point is at the origin, now we'll look at the other parts of the apparatus. This is the BH curve, part of BH curve tracer. This provides an AC voltage of 7 between black and red. This is the coil on which the AC voltage is applied. So the coil produces a magnetic field which is induced along the specimen. The IC detects the magnetic field. The IC is connected here to the power supply. One part of the IC has to be connected to the battery to provide the power to the IC. Here we get the outputs which has to be connected to the CRO. The output from the IC gives us the induced magnetic field. The output here gives us the magnetic field which is applied on the specimen wire. So both these magnetic fields are merged and we have to connect the X to the X channel of the CRO and the Y to the Y channel of the CRO. Once the connection is made, make sure the potentiometer is in the maximum mode. Switch on the circuit. Now we get a line on the CRO. This is due to the magnetic field which is applied. There is no induced magnetic field unless we keep the specimen. Now we shall keep the specimen wire. We can increase the width suitably according to the desired value. So the width can be increased. So now we keep the specimen wire exactly on top of the IC. So make sure the specimen wire is on top, directly on top of the IC. So the IC helps to read the induced magnetic field, and the IC has to be connected to the battery. Once the battery is connected, we can see the hysteresis curve on the CRO. We can adjust the volts per division to get a very good hysteresis curve. Adjust the focus and the intensity to make the image clear. After the hysteresis curve is obtained, note down the coordinates of A, B, C, D, E, F as shown in the manual. Note down the SV, which is volts per scale in the vertical direction, which is just above the Y scale, Y channel. Note down SH, which is above the X channel of the CRO. Here, for example, SV is 0.2 volt and SH is 2 volt. Plot the graph exactly as seen in the CRO. Mark the coordinate of A, B, C, D, E, F on the graph sheet and trace the BH curve exactly similar to the one obtained on CRO. Count the number of blocks enclosed by the curve and determine the area enclosed by the BH curve. Measure OB and OC from the graph. Use the formula to determine energy loss, remnant induction, and coercive field.